Hey everyone, welcome to Metaflow Office Hours. We have a super exciting session today. Our presenter today is Santosh Jha. Santosh has been with CloudKitchens for a little over 2 years, where he is building the next generation machine learning platform to accelerate the development and use of ML for all engineers. He's also a co-founder of Scientific Financial Management before, and then previous to that, he dabbled a lot in at the intersection of finance and technology with stints at AWS, Bank of America, Citigroup, etc. He's a degree in financial engineering from NYU. Santosh, thanks a lot first and foremost for taking the time to present here at Metaflow Office Hours. Over to you.
Thanks, Sri. Yeah, that's a quite an introduction. See if I can keep up with that.
You will, I'm sure.
So, yeah, so let's get started. I have a set of slides for today. So let me share those. Okay. Just a second. Yeah. So this is the I prepared some slides and we have the agenda. So I'm going to give some. So I know we're primarily interested in this is the Metaflow office hours. We're interested in Metaflow. So there is the initial parts are just building in some context, like where Metaflow comes into picture, right? What's the big picture look like in the platform, and then we'll see. So we can clearly see how Metaflow helps there, um, right? So this is the agenda. Let's jump into it. So first thing. So here at Cloud Kitchens, what we're doing right now is, by the way, everybody, I'm assuming you can see my slides, right?
Yes.
No. Okay. Yeah, so the machine learning platform 2.0, right? So we had a machine learning infra team, and we had sort of a lot of disparate tools, and the machine learning engineers and data scientists were doing machine learning. Like they will do machine learning regardless of, they have tools or not. Like they'll work around the obstacles and they'll do. So we had a bunch of tools and people were doing what they need to do, but not very efficient, right? There was a lot of room for improvement for sure. So we've been working towards this, and we recently launched this internally. We're calling it Machine Learning Platform 2.0, and we will look at the details of what it is and why we're calling it 2.0 versus what was before that. So these were some of the things so here 1.0 means that everything came before. There was no like launch of machine learning platform 1.0. It's like we kept adding more and more tools and tools, and at some point say, okay, we should take a step back, try to think about where, simplify things, where we want to invest more, where we want to prune, right? Be nimble, be lightweight, and move faster, sort of things. So this is the high level thinking was how we arrived at what we should be investing in for 2.0, what we should include, what we should remove, right? So we want to fix the abstractions. We want to allow people to have a clear mental model of what uh, things are, what tools to use, what entities to use when we do trying to do something, reduce the friction as much as possible. Like if you have an idea, you want to do something, there always going to be some friction, but we want to minimize it as much as we can. So you don't have to worry too much about, oh, now I have to wait for this another day because I don't have access to data, or I don't know where the data is, or I don't know how I have to allocate some infrastructure, or those kind of frictions can just kill the interesting idea you had. And then we want to make some paved paths, so make it easy for people to do the right thing. And so if they don't have any strong preference or reason, they'll just go on it and they'll do the right thing, and make it possible to do other hard things. So if they have custom use cases, they can still do it. They can go on their unpaved path, but there's always a paved path for doing important things. And the other part was we want to we wanted to make the set of tooling smaller. So it may not be intuitive here because we're a young company, but we just had a lot of tools, and we use open source a lot. Like for majority of thing, vast majority of thing, we use open source tools. But we end up getting a lot of tools, and there might be confusion to we have multiple things for doing same thing, and how do they uh, integrate together, work together. So that was one of the criteria as well. We want to simplify. Um, and then this is a little bit of history of what I'm talking about, the tooling. Yeah, when I say a lot, this is what it looks like. So we kept building all. You don't have to go into the detail of each of this, but you can. This is just to show, and this is the timeline created from our Git history. So when we added things to Git, and you can see, so we started in 2019 with Trino superset. That's basically our data warehouse, query engine, and interface. That's where it started. The first thing was if you have data, then people can use it to do some machine learning. Then we have Seldon, we introduced Spark, MLflow came for model registry. In 2022, we started having CUDA installed on the machines we use. And by the way, we use Kubernetes for everything. So Kubernetes is our compute layer. So everything has to run in Kubernetes. That's the issue. And also we don't use any managed service from cloud providers. So yeah, we try to be cloud agnostic. And so 20 beginning of 23 is when we introduced Ray. And that's when I think things started changing a little bit. It seemed like Ray can do heavy lifting of various different things and use cases, so that we started looking into investing more, and that looked more and more promising. We invested, build our custom infrastructure on to manage Ray clusters. And then the Ray was doing the distributed Python part, but the workflow side of things, as Sri was like chatting about, like most workflows, like most work looks like some kind of workflow. And Ray was missing that. You give it a job, and it can handle large scale of data, expensive processing very efficiently, all of that. But then if you have like a DAG kind of workflow, you have steps, and you want to do one step after the other, and then you want the way to resume from the last fail iteration. Ray didn't have that, and that's why we kept looking, and we ran into Metaflow towards the end of 2023. I think we looked at Metaflow before, to be honest. I think probably a year, 2 years before. At that time, Metaflow only worked with AWS, and we're not an AWS, so we couldn't use it. But then
Right.
we kept an eye, and we saw that support for other clouds were added, and then Kubernetes part, so Kubernetes Argo, that's when it became really interesting to us. And so Q4 last year is when we started investing more in Metaflow, and then now, yeah. So then we also introduced Poetry as our Python build system. So we have monorepo, and the Bazel was the build system. So Bazel for all programming languages, but Bazel doesn't work that great for Python, especially the dependency management becomes really pain. So now we move to Poetry for Python. So that has been really wonderful. Just the feedback so far. And so combination of these new tools, as we call the machine learning 2.0. So this is what it looks like currently. So the Kubernetes is the bottom layer, and then we have the Ray clusters, Argo, and MLflow sort of sitting there in the background server where you run your compute, your models get logged, registered, and then the top layer is where, as a user, you will interact a lot with. So that's Metaflow, the Ray Air libraries, and the Daft is our choice here for data frame processing. So Daft uses Ray as the backend. So that's our, we had use of Spark. Now we're replacing that with Daft plus Ray. And so Metaflow is bringing all of these things together. It's tying everything together. And the first thing users always interact with here is the Metaflow. So this is just some screenshots and some ideas of what the Ray. So this is what you see on the left is a standard Ray dashboard. What it shows you when you're on the job. On the right side is our the bottom right is what our custom Ray infrastructure looks like at very high level. So the part at the here, this is the open source Ray clusters. We use Kubernetes, so it's a kuberay operator that manages Ray clusters. And then we built this custom infrastructure to allow us to create, delete, update Ray clusters. And it allows us to have run as many clusters as you want. It scales up and down, scales down to 0 workers as well. Yeah, so that's the Ray part. This is the Metaflow that, there's nothing special here. We'll get to our customization later, but this is just what the Metaflow overall says, and I think everybody here is familiar with that. The Daft is this part. So Daft is also interesting. It's very young, so it's not has been battle tested everywhere yet. I think the biggest use case we found was that Amazon uses this for their data lake compaction jobs. We spoke to them actually, and that was the part that gave us some confidence that we can take this risk and use this. Yeah, it's a very young company, young library, but promising. So they have data frame APIs, and they have this planning, scheduling, execution part. It will break it down into small tasks, and then it will submit those tasks on this runner here is Ray. So it uses Ray very efficiently and it gives you nice data frame APIs to do like join and group and shuffle and all those operations. So Ray natively doesn't support a lot of them, especially joins, they don't support. And also like reading Iceberg, etc., like different table formats, all of that, that supports much better than Ray. Yeah, and then this is MLflow, just part here in the foundation. So we use that as a model registry, all the training experiments, everything is logged here, and then use the models from here for either for batch inference or real-time inference. We'll always refer to MLflow. This is the overall picture of what a user workflow looks like how will the user use it. So on the left-hand side, we have if when you're working with a workflow kind of situation, right? You have a job that requires a workflow, and so you use Metaflow, and this dashed boxes are optional. So you can run the same thing, for example, without Argo workflow or with Argo workflow. But Metaflow here is what the driver is, and then you have multiple steps, and then the sum of the steps can run on Ray. So we'll look into that. So this is the custom plugin we built using the Metaflow extension library. So it allows us to, it's called Ray step generally. So you can mark any step to be Ray step, and it will run that step on the remote Ray cluster. So you can choose which steps your entire workflow can be running locally or Argo, but you can choose to run specific steps on the Ray. And so you don't have to worry about how many CPUs or computer memory I need for step. You can just offload all the heavy lifting to Ray. And yeah, and on the right-hand side here, you have another thing. You also have, if you don't have a workflow, you just have a job, or if you have from a service, you want to just submit something, you can directly use Ray. So we have our custom SDK and things for our infrastructure that allows us to directly interact either CLI or Python client, Java client to submit, work with Ray directly. So that's the situation where you have a single job, large amount of data processing or something. Yeah.
Yeah, quick question here. So do users also get to pick the Ray cluster? Because you said in one Kubernetes cluster, you can have multiple Ray clusters because of the custom resource, like the kuberay custom resource. So assuming that there are multiple Ray clusters, when let's say, the the person who writes the flow, when they decorate a step with add ray step, do they also get to pick which ray cluster within the Kubernetes cluster they are going to submit this to?
Yes, correct. Yes. So we have, so yeah, that's it's called the address. So every Ray cluster has an address and then
Got it.
yeah, HTTP URL. So you'll pick that. You can use that from an environment variable, or you can put in your code. But different clusters will have different capacities, right? Different scaling ranges. Like for example, if you need bigger GPUs or you need more nodes, they may even Ray clusters can even have authorization to access data.
Got it.
So if you, yeah, so the way we allocate Ray clusters, the idea is like you want for one team or one project, you want to choose one Ray cluster. So that
I
way,
see.
because in Ray, what happens is you submit a job and it allows the job to expand. You don't have to specify how much compute you need, right? But the other side of the coin is now cluster has to allow you to run whatever you need. You can dynamically, one job can be creating more jobs conditionally, and then the cluster will just support all of that, whatever you need. But what
Got
that
it.
means is now you don't have isolation between the jobs. Like one job can consume a lot of the part of the
Yes.
cluster and the other job can starve. So there
Yes.
is some, so that's why if you don't want to have like a cluster for every one single person. It's possible, but probably just become like too many clusters and every person working in multiple. So you don't want to have thousands of clusters. But I think cluster for a few people when you're collaborating on a project makes sense because you're closely working anywhere. That's the idea. And that also allows you to like isolation at the compute level, but isolation at the security level. Like if you want to
Correct.
authorize the
Correct.
service account of a cluster to access some data, access some services. So that's how we do it. Yeah.
Interesting. Very nice.
Yeah. And then say, one second. All right. So now we get into the interesting part. What does Metaflow look like? So the general Metaflow, we all familiar with. I'm assuming everybody here knows Metaflow. This is like what additional things we have done or different things we have done here. So these are the three main plugins or decorators we built here. So our extension package is called CSS Metaflow, right? Following the standard um, instructions we have for building extensions. So the first thing here, the raise step part at the bottom is what I talked about, right? So raise step is you can mark any step as raise step, and it submits your job. So it will submit that part of code as a job, includes all the Metaflow code package, so you get all the dependencies. Also provides the pip dependencies using PyPy, and it will block for the job. So Ray job submission client is async, right? If you just submit the job and then your workflow will just go right to the next step, but the job is still running. So you have to, so we have to build that to block for the job and stream the logs. And when the job finishes, then you go. So even if it's running on the cluster, this wherever your Metaflow is running in your local machine or the pod on Argo, it's streaming the logs. And it's just not, it doesn't, because array cluster, it can be like, 100 nodes or whatever, versus this is single, but it still feels like it's running here. You can see the logs and it will go to the next step only when this one finishes. So that's the critical part of that array. So on the top one here is poetry. So this one is interesting. So because we started using Metaflow, and now the dependency management part comes in, right? So you have to supply all the third party and first party dependencies. First party is like your project depends on other projects in monorepo. So you want that when you're running. You also want all the transitive dependencies of including all the projects. And so PyPy decorator is there, but then you still have to supply like, so when you're running code locally, we use poetry. So you have the poetry toml file where you define your dependencies and you have poetry log files. So you have transitive dependencies frozen, pinned to versions. But then how do we pass that to Metaflow? So the default way without these plugins, it would be like you have to somehow put that in the code or somewhere the code can read. So that's where we built this poetry plugin where, so since we have the poetry log file, which has all the transitive dependencies. So this is a flow level decorator. If you mark a flow with poetry, it will detect the poetry log file in the directory, and then it will parse that and it will extract the first party and third party dependencies. First party are the local directories, and the third party will be all the pip installable directories. And then it will hydrate, it will attach the PyPy decorator to each step and hydrate that with all the dependencies you need. And it also attaches the Py module, which is another custom plugin here, which takes care of the first party dependencies, local directories. So each step now becomes like self-sufficient. It knows the first party third party dependencies, and it can run anywhere. It can run same machine, Argo, or on Ray cluster as well. And
This
the
is
Py
super.
module, yeah,
Sorry,
yeah.
sorry. Go ahead. No, go ahead. Complete your thought.
Yeah, the Py module is the second one, which reads the, so it will detect, it will parse the first party dependencies or projects you depend on, and it includes that in the Metaflow code package. So right now, the default, the code package only includes the current directory, and the suggested solution documentation, you can use symlinks. But yeah, we found the symlinks to be not very friendly. It was very confusing. Like you have symlink to another project, but then project needs another one. It can get very complicated very quickly. Like if you have the workflow independent of the rest of the part, that's one thing. But if you have monorepo, you have a very complex dependency graph. You have
Mm-hmm.
common libraries and things that everybody wants to use. So Symlink wasn't working. So this Py module is basically, it's adding to the code package, and it's also adding to the syspath. So your currently running process also can see other projects, and it goes to the code package so Argo and other remote executors can see it. And raise step here also actually uses both of them. So the raise step uses the same code package that was built for Metaflow. It
Mm-hmm.
downloads and then it passes that. It downloads and extracts in a local temp directory, and it points the Ray job to that, saying this is my working directory. So so that's why it can run on Argo or anywhere, because as long as you have the Metaflow code package, it will use that. And it also uses all the third-party dependencies from the PyPy and turns them into requirements file and passes that to the Ray step. So on the Ray step, what actually when the Ray job runs, it's actually running the Metaflow command, the Ray step, and all the run ID, task ID, all those things in there. And it gets the code packages in the working directory. So this is like a translating the Metaflow world to the Ray world. So Ray has
Got it.
working directory, Metaflow has code package, right? Ray has pip runtime environment, Metaflow here has PyPy, and so we were doing the translation. So it is not using exactly the Metaflow way of like virtual environment. It has its own virtual environment management, etc.
Mm-hmm. Mm-hmm.
And it does the caching, everything. But we're just doing the translation in this plugin.
Got it.
Yeah.
Cool. I thought of a question for the at poetry decorator, which is you mentioned was a flow level decorator.
Yeah.
So at the flow level, you look at the poetry.log, you see all the dependencies, and yes, there is one path which is to add the PyPy decorator to every step, so each step can kind of sort of get the packages that it needs. Uh, did you consider kind of like creating a Docker image maybe that has all of these dependencies that you think of that you parse and then use that Docker image for individual steps?
Yes, true. I mean, so you're saying like Docker image running the Docker image locally? We had considered running Docker image for Argo and Ray. That's what we're
Uh-huh.
going to do. but not
Okay,
locally. Yeah,
I see.
yeah.
Actually, that's correct. That's correct. So if you are running locally as well, then Docker image is not as useful. There, like at PyPy is probably the only option, or at Conda if you want to
Yeah.
go down that path. Okay, that makes sense. I was talking more
You,
on the running on Kubernetes or on the Ray, where it is you could give it a Docker image and say run this Docker image.
so yeah, so that's a good point actually. So the way we think is that when you're iterating, right? Let's say if you're trying out, should I use this library or not? When you're writing code or you're making major changes, at that point, building a Docker image for every iteration, it kind of slows, right? And we
Fair.
cannot push the Docker image to production because this iteration is working in production directly. You're
Got
working
it.
because your data is in production. And
Got it.
if you want to push the Docker image to production so that it's available to Argo, it's going to take some time to go through CI/CD,
Fair,
and
fair.
we don't
I see.
want those extra few minutes of delay. So
True.
you iterate through like this way. Once your code is stable, you realize this is, then you will just build an image, and then you use that image for Argo and Ray clusters.
Got it.
So that way you basically you work on your requirements when you're working, and your code and your dependencies. And then once they get a little bit hardened, you push them down to the image. The image
Got
is
it.
your lower level. And you
Got
can
it.
have, like, it's not all or nothing. You can have some things in the image and you can just
Yeah.
iterate on a smaller set on the top.
Yeah.
Yeah.
Awesome. Very cool.
Yeah. And this is what what I described the interaction between the plugins look like. It might be a little hard to see this image, but is what I just described how the poetry plugin comes in initially and then attaches the PyPy to each step. That PyPy is used by Argo workflows and also used by Ray, right? And same thing with Py modules, also used by Ray and Argo workflows. So Ray and Argo are basically our workhorses here. Um, right now, I think we're not focusing on anything else. I think these two are sufficient for all of our use cases at this point. And yeah, and then the legend, the color coding here is all the yellow boxes is what our custom things are, right? And then the dark blue ones are standard Metaflow things. And then the shading here, so Argo Workflow plugin is green because we had to make changes to Argo Workflow plugin. Argo was assuming that it's everything is running on Kubernetes part only, and it wasn't like accepting what Ray plugin was doing. So we have a fork and we have some changes to make it compatible to also allow to run the Ray steps on there. And the PyPy decorator is also a lighter shade here. That's because we had to change that to the cross-platform dependency building, particularly. It's still not that easy because, and it's probably because the limitation of pip itself, not Metaflow for so much. Because if you're building, so if you do just pip install a library, it does it for your current platform. But if you want to do target platform, then you specify a platform different than what you're running on. In that case, if you have the binary wheels available for all your transitive dependencies, then it works fine. But that's not true in real world. A lot of libraries have like source distributions that require building, and yeah, it gets so we have to relax this a little bit to allow, like PyPy by default doesn't support source wheels cross-platform. Okay, so we have to do that. We have to relax the isolation a little bit, and there's some rough edges. I'm still working on that, but right now I think it's mostly working. So that's the story here. All right. And I just have some things I want to share, like what our experience has been so far. Metaflow, I think it's been like probably 4 months, 5 months been using Metaflow. And yeah, so the developer experience is great. We love it, how fast we can iterate. The code looks pretty good. Everything is one place. You can see it looks like a regular Python code and doesn't force you to look like something else. And the dashboard is amazing. We love that. You can see everything in one place. So in our dashboard, we can see the logs from Argo parts, from Ray, all of that in one place. And you can see the DAG, and we touched a little bit on the cards, but we definitely want to build more, so make it even more helpful. The extensions are great. There is a great way to extending, and we could find our way and whatever fits our needs by building those extensions. We weren't blocked by asking Metaflow community to change something more general. Like this allows you to move faster. We can build for what fits our need, and then if it's helpful, we can contribute back to the community for others to use. But at least it unblocks us pretty fast. Um, and then we could use Argo workflows. That's a plus point for us. It allows us durability because that's what the production and all the long running things are gonna be. Like we don't want people to. It's not convenient to run a long running workflow on the laptop. Also, from security point of view, we want the paved way to be in such a way that nobody downloads data on the laptops. So that compatibility with Argo was a really good plus point for us. The bottoms are here, so like managing the dependency cross-platform. I mentioned this is still taking a lot of time, and probably, I still want to make it work, but probably in the longer run, we'll rely on the Docker more. So we probably can invest a little bit more onto how to make it reduce the friction on the Docker part as well, so allow people to do it more frequently. And the Symlink solution for the dependency on other project, that really I want to say, like I think we could do better. I think looking at what everything else Metaflow does is amazing. This one looks like we shouldn't do it. We should probably take the Pi module plugin and allow people to use that.
So can you expand on that a little bit? Like, where do you need the Symlink? This is for as part of the Metaflow extensions, which we're creating a new extension. Is that where this is needed?
So if the Pi module is our solution to not using Symlink.
Oh, I see. Okay. Yeah.
Yeah.
Sure.
So we had to create Pi module because the symlinking seemed hacky and also
Yeah.
gets very complex when you have
Yes.
transitive symlinking.
Fair.
Yeah.
Makes sense.
Yeah. That is it. Now we can talk about questions, general comments, future work, etc.